Hi, in this video I'm going to talk to you about how to do basic statistical analysis in Python. So we'll be using pandas, we'll also be using scikit-learn, we'll also be using the scipy package. So first we will import those packages and then we'll import the dataset that we're going to use. So that its dataset is the size of the brain. So it's the healthcare related data, and these are the variables that we have. We've got seven variables, seven columns in total. So just to see how many columns and rows we have, we'll use the data dot save, and we get 40 rows and 7 columns. If you want to see which columns are there in the data set, simply use data dot columns and it's going to give you the number of columns that we have. Suppose we want to see a particular variable, the data in a particular variable or a column, we use the square bracket and within we use the quote to get the data in a given column or given variable, and we will print the column, and this is how it looks. We can do that for other variables also if you want to see which values are there in a given variable. Okay, the next thing we will see is how to create a summary statistic, how to get the summary statistic of the data. And given that it's all numeric data, we can get a summary statistic for all of them except gender, where it is male and female. For other variables we can get. So gender is the category. If you're familiar with SQL, well, you can always use the group by. We can also use group by here. So we create a new variable group by underscore gender, and so data dot group by. So group by method actually get you this these categories male and female, and then we can use that in order to get the summary statistic separately for male and female. And how going to do that? So here is an example. We write a for loop and then we use gender as a variable to sort of get the summary statistic in a group, in a cat, with respect to the category or with respect to the group. Okay, and with group by underscore gender, the variable will have both male and female. So we will get we'll use the value dot mean because value is just a variable that we have assigned, and it will basically, what it will do is that it's going to take the value separately for the different categories within group by underscore gender, where we have only male and female, and we are getting mean here. The summary statistic we're getting here is mean, right? So we're going to get the mean of the variable VIQ separately for male and female, and that's where we get it. Okay, so if you want to get it for more than one number of variable, that's also possible. We can get it for other variables, we can get it for all variables at once. But in order to get all variables at once, we do not have to sort of use a for loop. We can simply use dot mean, and it's going to give for all the variables, all the quantitative variables in the list. And in case we simply want the total average without getting it with respect to the categories such as male and female, we can also get it. Okay, so how do we get it? We use the variable. Okay, so we use double quote and square bracket, and then we use the mean method, and then it's going to give the average, the sample average, right, without separating male and female. Next we'll see how to create a matrix, like a scatter plot matrix, a cross tabulation matrix. Well, how do we visualize data? Okay, so we can use a scatter underscore matrix. So we'll use plotting.scatter underscore matrix, and we'll do that for 3 variables, and here you see how it looks. Okay, so we get to understand the relationship between these 3 variables through this, and that actually helps you to understand the relationship with these variables. Next thing we'll see is how to do hypothesis testing. So we'll import scipy from stats. So First we will do the one sample test, and here is the one sample test. So one sample test is like you're testing the average value or some sort of a summary statistic of a given variable with a given value. So here we see we want to test whether the mean of VIQ is equal to 0 or not. So that's the null hypothesis, that mean of the average value of VIQ is 0 and the alternate hypothesis is not 0, right? And what we get here is that, so we use t-test underscore one samp. So that if we use that, it's going to give you the one sample test, and we see the p-value is 1.3, so it's not significant. So we reject the null hypothesis, and it shows that the average value is different than 0, not equal to 0. Then we'll do two sample tests where we assume that the distributions are from two different samples. So so here it is. So we take two variables, okay. One is female VIQ and male VIQ, okay. Sorry, I just made a mistake. It's the value taken, it's two different samples taken from the same assuming that they are of same distribution, okay. So we have gender male and gender female, and we want to know whether the mean of these independent samples, but assumption is that the distributions are the same for both the female VIQ and male VIQ, whether they are same, okay, whether the mean is same, there is no difference in the mean. Here also you can see the p-value is greater than 0.05, so at 95% confidence level it is not accepted, so they are different, so they are not same. But as I said, we assume here that the distributions are same, and often the case that distributions are different, and distributions are also different than the normal distribution. In t-test, the assumption here is that the data is distributed normally, which is often not the case. So in that situation, when you do not want to assume any statistical distribution for your data, you can use non-parametric test, and one test you can use it Wilcoxon sign rank test, and you can use the stats.wilcoxon, and then we can sort of see whether FSIQ and PIQ have the same average, okay. But we do not assume anything that they come from same distribution, such things, or they both have normal distribution and so on. And the p-value here is 0.1, which is greater than 0.05. So again we do not accept the null hypothesis, and we say that they're different, the average is different. Now we'll see how to use how do we do a linear regression. So we'll create a simulated data set. So we're going to create a y and x. So we first simulate x values using the lean space from numpy package. For that we import the numpy, and then we create a y variable, which is just using the random value that we created previously, which is x, and using that in the equation, and you'll always get a random y value also. But there is some relationship, because this is a linear relationship, so we assume some sort of a linear relationship between these two values, y and x. And how do we run the regression? Well, from start smalled, we will import OLS, and then we'll use y as the dependent variable, x as the independent variable. When you say dot fit, it's going to fit a linear regression, ordinary least square regression model to that. And here we print the summary of the results, and we get like R square is equal to 80%, which is good, which is expected because we already had sort of assumed a linear relationship. The only varying thing is this one, otherwise it's more linear, so we were expecting a higher R square, which is we can see here. We can also see the coefficients So here is the coefficient 2.93 is the coefficient or the beta estimate for x. Standard error 0.3, t statistics 8.6, p-value is close to 0, which is extremely significant because it's less than 0.05, 0.005, sorry 001. So it is not only significant as 95%, it's also significant as 99%. Alright, so that's the way you do a simple linear regression where you only have one independent variable. But you can also use multiple independent variables. Okay, so we can also do a multiple linear regression. How do we do that? So I will create another simulated data. So this time I'm creating x1 and x2 using pretty much the way we did last time, and then I'm creating y variable, but using both x1 and x2 because both x1 and x2 contribute towards the distribution of y. That's the assumption in the multiple linear regressions. Okay, now that we have y and two independent variable, y is the dependent and x1 x2 are the independent variable, we will fit an ordinary least square regression model, and this time this is a multiple linear regression model, right? So y is the dependent, x1 x2 are the independent variable, and when we print the model summary, okay, syntax is same pretty much. We did the simple linear regression. The R square comes out to be much less, which is 12%. We'll also other variables like AIC, BIC, which are used for model parsimony, also used for model selection. So this method always converges, so you will never get whether it's converged or not, it didn't converge, because ordinary least square regression gives you the closed form solution, so you will always get results. So it's never like it never converges. So it's not like maximum likelihood or gradient descent or so on. The p-values in both cases are above. You see 0.05, so both are not significant. So none of the variables explains the distribution of the dependent variable. So that's how you do a multiple linear regression using Python.